Right, getting ready for our trig unit test here, doing the preview. Starting with some application problems here at the top. We're going to have to draw some pictures, but that's all right. So we got a 25-foot tall tree. Now, I tend to draw all my pictures the same. You do not get extra credit for having fancy artistry, so sorry about that. Okay, 25-foot tall tree casts a 14-foot shadow on the ground. We've talked about this a lot. Shadows on the ground. Can't be more specific than that. What is the angle of elevation? Elevation, depression, doesn't matter. Put it in the bottom corner. So again, draw and label your sketch. Set up your trig proportion. Now, we talked before about this too. When I'm labeling my sides, opposite the right angle is my hypotenuse. Opposite the angle I'm looking for is my opposite, and then adjacent's my other. So, I start to look. Again, just a reminder here. So I look and I go, okay, so I've got O and A. Oh, it's going to be T, that's tangent. And when I'm looking for an angle, remember, the little -1 is my reminder that when I go to punch this in on the calculator, that I hit second in tangent. So I get the little -1. Then I just punch in the parts that are left. And typically here we're going to go to the nearest tenth, so it looks like about 60.8 degrees. Okay, not too bad. Next one, we actually get a picture though. From the top of a 160-foot tall tower, there's my 160, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? Now you're like, well, wait a minute. I thought you said the angle measure always goes in the bottom corner. Why is it up here? Remember, that's not even inside the triangle. Okay? My actual angle I'm using is still inside. Still in that bottom corner, just like it has been all along. So I look again and I go, okay, so I got opposite and adjacent and hypotenuse. But again, I have opposite and adjacent. But this time I have the angle measure. So I have the tangent of 19 degrees equals opposite over adjacent. And we've talked time and time again on this, on how we'd have to work this out. We look at this and we go, okay, x is on the bottom means I'm going to be dividing by my trig function. Well, what if I don't remember the shortcut? What if I don't remember the trick? Okay, if I don't remember the trick with this, I go, okay, well, let's see. X is in the denominator, so I got to multiply by x. I can't multiply by 160. That's not in the denominator. And so this one takes an extra step. Because when I multiply by x, I don't get it by itself. Now it just moved. So what am I doing to x? I'm multiplying it by this tangent of 19. And to get that taken care of, now I've got what I need. Okay, so algebraically or by the pattern, either one's fine. No seconds this time, we're not looking for an angle. So about 464.7. And get that set. Convert radians to degrees or degrees to radians. Remember, if it's in degrees, we put pi on top because we want it there. Do not leave it like this. If you can simplify the coefficient in front, you need to do that. Little math interaction doesn't hurt nothing. Okay, 8 over 9. So that would be 8 pi over 9. And we're good. So we do that for each of these. And again, all I do is punch the non-pi part in. Little math interaction. And I can get my answer for that one. When I'm going the opposite way, though, I'm going from radians to degrees. That's when I flip my fraction over because I want the pi's to cancel. And then I just multiply straight across. And, of course, simplify it as much as I can. So if you're ever confused, go to the ones with pi first, and then you're going to be like, oh, those are 180 over pi. Oh, so these are the other pi over 180. We'll wipe those guys. We'll multiply across. And simplify. Okay, so nothing too bad so far. Now don't freak out when you see this next one. You're like, well, this doesn't look like an application. Read it through. If the minute hand of a clock is 11.5 inches long, how far did the end of the minute hand travel? From 7 a.m. to 11 a.m. Hint, just 1 second here. Excuse me there for a second. I was about to start coughing crazily and I didn't want to do that in the middle of this. So how far does the end of the minute hand travel from 7 a.m. to 11 a.m.? Well, think about it for a minute. Every hour it goes all the way around. Okay? All the way around 360 degrees, or 2 pi. So in 4 hours, if I'm going around 2 pi, or 360 degrees every hour, because every hour it goes all the way around, that'd be 8 pi. So I gave you what theta is. I gave you what the radius is. So all you have to do now is multiply them together. So when we multiply those together, we end up with 92 pi. But who goes up to somebody and goes, yeah, that moved 92 pi inches? Yeah, like nobody does. So you can do it a couple of ways. 92 second, and the caret button will get you straight up pi. Okay, I can get it. Or if you just want to use 3.14. You're like, well, wait a minute, it's a little different. It's like 288.9 versus 289. I'm not going to mark you off on that, okay? I'm still just going to use 289 here. So just something to ponder as far as that goes. So as we start the inside. All right, now we're to graphing. Okay, make sure we label things. Reminders. A is my amplitude. A is how high we go up or down. So here my amplitude is 3, which tells me my top value will be 3. My bottom will be -3, and if you want, we can even put the extra lines in here. My period is always going to be 2 pi divided by b. And if I don't see a number in front of my angle measure, we assume b is going to be 1. So in this case, my period is 2 pi. So I get my 2 pi on it. And then we've talked about the couple of different ways you can get the other values. Well, what's in between 0 and 2? 1 is. And I can put pi or 1 pi, it doesn't matter. What's between 0 and 1? A half, or 1 pi over 2. Well, now what? A couple of different ways I could get that other value, or even the 1 pi over 2 if you weren't sure. So I'm going to do it for this one right here. So what I could do is add up the two endpoints, so 1 plus 2, divide it by 2 with a math enter. 3 over 2, and I just put the pi with it. Now we've also talked about how I can do this with a pattern. If I know my first value, 1/2, I'm just going to keep going up by 1/2 each time. I'm just going to keep adding a 1 to the numerator. 2 over 2 is 1. 4 divided by 2 is 2. And then I'd say, oh, there's the 3 over 2, and I just put the pi with it. They both work perfectly fine. But you've got to have a grip on one of those, because I'm not going to tell you how to do it tomorrow, because we've done this like a dozen times already. So now my last thing I got to think about is, where does my sine graph start? So one of my graphs starts at 0, and the other one starts at the min or max. What about sine? Hopefully somebody said 0 at this point. So 0, max, whatever my a value is the first value I'd go to. 0, min, 0. because my sine graph should always look like a sideways S. Sine S. See? Letter B. I notice it's cosine this time. No number out in front, so my amplitude would be 1. I do have a number in front of my angle measure this time, so my B value is 2. So my period is 2 pi over 2, or pi. And again, that would be my last value that I'd put on here. Now, if I kind of take a peek up above, I get a little bit of a hint. What's between 0 and pi, or 0 and 1 pi? Pi over 2. And again, if you're not sure on what to do for this one then, suggestion, 0 plus 1/2, got to have the parentheses around fractions, divide it by 2, because we're looking for the average, which would be 1/4, or pi over 4. And then again, think pattern, or you could plug it in your calculator. 1/4, 2/4, 3/4, 4/4. 2 over 4 is 1/2. 4 over 4 is 1. So that'd be 3 pi over 4. My amplitude is 1. So get 1 and negative 1 going here. And then cosine starts at whatever your A value is, which in this case is 1. So 1, 0, negative 1, 0, 1. Because it should look kind of like a big U shape, not V. And we're set. Little things, little things, little things. I get to C. Now this time, silly man, I didn't put in the amplitude and period slots. So, my amplitude, value in front is 1. My period, no value in front of the x here, would just be 2 pi, but I have a C value this time. What direction does that plus 2 mean? We're going to shift everything. 2 up. So, I'm going to use those lines a little differently this time. I've already got my period up at the very top, back on letter A, so I shouldn't have to do all these calculations again, because I've already got them done. But now this time, remember, the ones with the up and down shifts are the ones where we do dots and then we shift them. So it's kind of like I ignore the plus 2 the first time through and just graph sine with an amplitude of 1 and a period of 2 pi. So if that was true, I'd go 0, 1, 0, negative 1, 0. But then I'm going to shift them all to up. So my initial 0 goes up to 2. My 1 goes up to 3. Back to 2. 1, 2. 1, 2. And that is the one that I'm actually going to graph. Some of you have told me you're comfortable enough to do it all in one. That's fine, but just make sure you're very accurate with all your points, because I will be watching. Okay. But again, sine curve, S shape. Why do I make mention of that? Because letter D, we have another shift. Down 1, but nothing else changes. Okay. Anything is fair game to change on these problems. It could be amplitude, it could be period, it could be a vertical shift. It could be 2 of them, it could be all 3. So you have to be ready for that. I'm just saying. We didn't change the period this time, so we don't have to play with this stuff. Get those guys ready. So now my typical cosine graph starts at 1, goes back to 0, back to negative 1, 0, and 1. Then I have to shift them all. So back down to 0, down to negative 1, down to negative 2, down to negative 1, and back to 0 with my curve. Okay. But graphing, there's tons of videos on the website if you need some more graphing help and things like that. Use Sohcahtoa to answer. Again, the one tomorrow will look just like this. So if you're trying to remember on the front with the applications, oh crap, which one is it? This is inside, so don't flip out. Get my sides labeled. Hypotenuse. There's my opposite, because there's the angle I'm using, which makes this adjacent. So what have I got to work with? Opposite and adjacent. Tangent. I already got tangent happy on this. So tangent of the angle that I'm given, got to use that, is opposite over adjacent. And like we talked about earlier on the story problem we had, if x is on the bottom, I need to go ahead and x is going to be the number divided by that. Or I could do it out algebraically like we did, like I said on the problem earlier. So let's see here, 42 divided by the tangent of 28. Looks like 79 to me. And we're set. If I'm looking for an angle, holy cow, I did go tangent crazy. I will not go this tangent crazy on the actual test. Because again, I ended up with tangent. Nice going, Hardy. It's an angle, so I need my -1. It's opposite over adjacent. Again, I make sure second tangent, got to have a little -1. So about 36.6. Or if some of you like doing angles to the nearest whole, I'm really not that picky. But I've got to keep labeling things and working stuff. More radian to degree, degree to radian. Can you tell I'm trying to make sure we've got this down? Again, if you're not sure, do the radian to degree one first, because you know that's going to be gone. You're like, Hardy, you didn't finish 11. I know. Again, that part with math, enter, to get my radian measure. Once I eliminate the pi or the radians and the one on the right, multiply across and simplify. Keep it simple, keep it simple, keep it simple. Now as we get to the back, reminder, this is how yours looked originally. Now if you've been here any of the days since then or grabbed them out of the folder, that should have been fixed by now. But I will redo mine on here in case I have some of you that are a little behind the game here and had not made the adjustment. And no, you will not have to do this tomorrow on the test, as in redraw this for me. You will have these on there, but you will not have to draw them yourself. Okay, well, we'll start with this one. So I look at this and I go, okay, so I need to figure out what these two numbers are going to be when I'm doing this. They're sine graphs, so I know that part. My amplitude, again, is just looking to see where's that first value when I get up here. What's my A value? Well, up here, that value is 2, so that'll go in here. Then I notice that the period is pi. So if the period is pi, 2 pi over b has to equal pi over 1. Because they have to be equal to the same thing. So we've done this before. We're going to cross multiply. And then whatever's with b, which is just pi, we divide by, and that, ladies and gentlemen, gets me my b value. And I've got my equation. Okay? You've got to be able to deal with some things like that on here. So again, let me get this one updated. Hopefully for future reference, those of you watching this will have had ones that were already done and you're going to be wondering what the heck I'm even doing. So let me get this drawn in quickly so we can all be doing the same thing. Okay, so what do I notice? I notice the first value, not at 0, is down at -3. So I put that in for my A. Again, that's not my amplitude. My amplitude would still be 3, but the A value can be different. It tells me it opens down. My period is 2 pi, which is normal. Because if you think about it, 2 pi over b equals 2 pi over 1. Well, if these are the same, these have to be. And you could put the 1 with the x, you can just put the x. Doesn't matter. And say okay. So we got to find our period, we got to find our b to be able to do that. And we're coming down the home stretch here. Write the cosine equation for the given information. Okay, there's my A, but this is not my B. Just like we did up above, we got to do a little math work. We got to figure out what B is. So we cross multiply. Whatever's with B, we got to divide by all of it because we want B by itself. And if you get a fraction, leave it. Okay, please do not go to 1.33. That's kind of borderline silly. Just plug that in for my B value. Because just like up above with the sine graph, it's A and B is what I'm looking for. And then the extra credit in the quiz, not in the preview, okay, is sketch 2 periods of the trig function. Can you extend the pattern? So I'm like, all right. What do we got here? So I got a sine graph, okay. So my B value is 1/2. So my period is 2 pi over B. Now remember, when you're dividing by a fraction, if you're going to put it in the calculator, do it without the pi. Divided by 1/2 in parentheses. I get 4. So this is going to be 4 pi. So 4 pi. What's in between 0 and 4? 2. What's in between 0 and 2? 1. 1, 2, 3, 4. Sine graph. Starts at 0. Be careful. That A value that's in front tells me where my first value besides 0 is going to be. So I open down. If that was positive, I'd have opened up. Back to 0, back to the top, back down. But remember, to get the extra points, you've got to sketch another period of this. So I'd need 1, 2, 3, 4, 5 lines. But the cool thing is the pattern doesn't look very hard. 1, 2, 3, 4, 5, 6, 7, 8. And just keep going. She's like 0 top, 0 bottom, 0 top, and I end up back at 0. Okay, last big summative. Let's do this up well. Most of you did very well on the last quiz, so I'm assuming that will happen again on this. But again, if you have any questions, make sure to have a chat with me so we can have you in the best shape possible moving forward. You got this.